Welcome back to part 5 of the Platinum Refining Stockpot 4 video series. The weather was okay. We made it through the storm just fine. I'm going to start by removing this platinum solution. This is the platinum solution that we precipitated with oxalic acid out of our main solution. We were looking to precipitate gold, but we got platinum. So I dissolved it in aqua regia, and that's what this is. We're going to work with this a little later. I'm removing it. I'm removing the ammonium chloride solution. We'll save this for later use. This is just a saturated solution of ammonium chloride. I'm going to move it to get it out of the way. These are the small pieces of gold that I recovered with the oxalic acid. It's highly contaminated with platinum group metals. I'm going to set this out of the way so we don't lose it. Let's move this out of the way. This is just some palladium and platinum in solution that's infused with ammonium chloride from this experiment. So we're going to move this out of the way. Now what we'll do is redissolve this experiment with a little distilled water and a little bit of hydrochloric acid. Now we're going to add a little bit of heat to this and try to redissolve those solids in there. While we wait for this to redissolve, what I'll do is get this solution here, or the solids here, out of this beaker. This has been setting for a few days. You notice that the solution is starting to turn a little bit of color. These metals will do that if they're allowed to set in the acid solution for any length of time. So this is the these will be the metal solids that we precipitated out of the sulfuric acid solution with zinc. Alright, here's the metal that we precipitated out with zinc. This will be a waste solution. It does have a little bit of precious metals in it. You can tell by the color. I'll move this out of the way. Now what we're going to do is use a clean beaker here. I'm going to try to rinse the metal that's in this beaker off with some water. Try to get all the acid, or as much of the acid as I can, rinsed off of there. Sticking together pretty good, thankfully. This is the metals that we precipitated out of the sulfuric acid boil that we did, that pulled copper, precious metals, palladium, platinum, even some gold. So at least we got our metal back out of that sulfuric acid solution, so we can work with it. I've given this multiple rinses with distilled water to get the sulfuric acid off of it. And so now we're ready to go to the next step. At least we got our metal back out of that sulfuric acid. Now we're going to add a little bit of hydrochloric acid to these solids that we just recovered out of that sulfuric acid solution. And we're going to try to put this stuff back in solution now with a little aqua regia. Here's some nitric acid. Here's what the solids are looking like since we added the hydrochloric acid. Set this up on the heat now. And what we'll do is add a couple of shots of nitric acid. See if we can get this to go back in solution. We've got both of these solutions slightly boiling. What I'm going to do is pull them down off the heat now and let this cool off before we proceed. I've allowed the solution to cool completely. Now what we're going to do, I've got my saturated ammonium chloride. And what we'll do is try to precipitate out the platinum now out of this solution. Now that we've rehydrated it and dissolved the crystals with dilute hydrochloric acid. If this works, we gather up our platinum and proceed. If it doesn't work, we're going to punt and figure out what we're going to do next. Here we go. Ammonium chloride going in. I don't see any platinum salt coming out of solution, so I'm going to call this a fail. And so far what we've done is we've tried some new techniques here to get our metals separated. We tried the sulfuric acid boil to remove some copper, and that didn't work for us. Pulled a bunch of other metal with it. Then I used the oxalic acid to try to pull some gold out of it, and that didn't work. We got platinum pulled instead with the oxalic acid. So now what I'm going to do, we tried all those new things, they didn't work. I'm going to set this up here out of the way, and we're going to back up and go back to square one and start all over. So here we go. I'm going to save the platinum. This is a fairly pure concentrated platinum solution. I'm going to set this off to the side. Now I've got a piece of zinc here. I'm going to add all these solutions together in one beaker over here. And we're going to start cementing the metals back out of the solutions onto the zinc. Just add all these solutions right back into this large beaker here and get our metals back out and start all over. All right, let me add this solution here that we tried to precipitate the platinum out of. I'm going to pour this right into our reaction beaker here and cement these metals out on the zinc also. Alright, we've got most of the metal cemented out on the bottom of this beaker. It's down here is a black powder. What I'll do is add a few more pieces of zinc and complete this cementation process. This reaction went fairly well. I've got a little piece of zinc down in here still, I think. See if I can get that out of there. Or is it? Okay, there it is. There's our piece of zinc. See if I can grab this with some tweezers. Alright, I'm just going to have to pull it up to the top and grab it out. Here we go. It's just a piece of zinc. Now what we need to do is get this acidic solution off of our black powders. If we leave this solution on this material, it'll tend to want to go back in solution. So I'm going to pour off this solution now. And here's our cemented material back in black, cemented on zinc. Now what we'll do is cover it with some distilled water, get that acidic solution off of there, and just let this settle now. See if we can get our black powders and proceed from here. I've allowed the black metals to settle overnight. Here's our material. What I'm going to attempt to do now is pour off this waste solution, get rid of it. I've been rinsing the powder over and over with distilled water. I think what we're going to do now is try a little bit of hydrochloric acid, which we need to do anyway in order to, there's some kind of compound in there that's not precious metals. It's probably zinc chloride or something. But I need to try to dissolve that material out of here. So what we'll do is add a little bit of distilled water. I'm adding a little bit of hydrochloric acid. And this should help clean the metal up and dissolve out any traces of pieces of zinc that might be left in here. What I'm looking for here is any kind of bubbling or fizzing that indicates we still got metallic zinc in there, and I don't see any indication of that. So what we're going to do now is tip the beaker on its side and allow this material to settle out. All right, let's pour this off. There's a little bit of black material that's piled up in there. See that? This stuff is so difficult to work with. It's just difficult. I think what we're going to do is continue to rinse the black powders now with some hydrochloric acid. Hydrochloric acid. Straight hydrochloric acid this time. Let's see what that does to us. These hydrochloric acid rinses seem to be helping out. So what I think I'll do is continue with these until the metal gets cleaned up and we'll go from there. Yeah, it's doing pretty good. It's looking good in there now. Let me try some distilled water on the black solids in here. And what we'll do is put this up on the heat. Give this a quick boil in some distilled water and see if that helps. The black powders have been on boiling now for about 20 minutes. And what we're going to do now is try an experiment. We're going to add a little bit of hydrochloric acid to a beaker here. I'm going to add about 100 milliliters of hydrochloric acid. What we'll do is pour this right on in slowly, carefully, and then we're going to have to sit here and babysit this, because if it starts turning color in there, then that means we're putting metals into solution. And this is trying to clean up the metal and get all the compounds that are in there with it off of the metal. So we'll just see what happens now with this dilute hydrochloric acid boil. The metal's been on boiling now for about a half an hour. What we're going to do now is pour this solution off into a waste container. Now let's let it settle down a little bit. It's ejecting the bubbles are ejecting the metal up into the solution. It looks mighty good here. Okay, let's go ahead and pour this off now. This looks really good now, really good. I think this was a good move. Boiling it in dilute hydrochloric. It's got the metal nice and clean. Now we're going to cover the metal with a little distilled water until we figure out what we want to do next. What I've been doing is rinsing the black powders over and over with some distilled water and pouring it off into this waste container. A little bit of the black material starting to suspend in there, and that tells me that we're getting pretty close to having this material cleaned up nicely. Now what I'm going to do is reach down in here with a piece of pH test strip. Let's see what we got for the pH on here. Fairly close to neutral. And my thoughts here are that if I get all the acid rinsed off, then it's safe to conclude I've got the chemicals rinsed off also. What we have in here now is some clean platinum group metals. a little bit of gold, and a little bit of copper. So what we'll do next is, first step is to try to remove the gold from this. In order to do that, I'm going to have to put this material back in solution. So what we'll do is I have some hydrochloric acid, and we'll add some hydrochloric acid to our black powders here in our beaker. That's about 300 milliliters. Now we'll cover this up, set it up on the heat, and start heating it up. I've got some 29% hydrogen peroxide here, and we're going to use this to dissolve our mixed black PGM powders. I'm going to measure out about 200 milliliters here. So now what we'll do is we'll start adding our hydrogen peroxide to the mixture of black PGM powders and hydrochloric acid. Try to get this to go back into solution now. Look at that. That pretty red color forming there. That was about 25 milliliters that we just added. Add a little bit more. I've turned off the heat and allowed our solution up here to cool completely so that we reduce the chance of any vapors escaping into my work area. This stuff is highly toxic. Look up the word platinosis for full details. I've got some long gloves on to prevent this solution from spattering up onto my skin. And you can see we've got a little bit of material left down here in the bottom of our container. Here you can see I've got some undissolved material in the bottom of the beaker. Not sure what that is. Let's go ahead and add some hydrochloric acid. Now what we'll do is set this up on the heat and start heating this up. Now what we'll do is start adding some more hydrogen peroxide to this material up here. I don't know what's in there, but let's try to see if we can get it to dissolve with a little bit of hydrochloric acid and hydrogen peroxide. I'm just going to start adding a little bit here before it's even heated up completely. See what we get. What kind of reaction. It is changing color, and it looks like we're still putting something in solution there. Let me give it a quick stir. I don't know what that is. It might be gold, might be some more platinum group metals, I'm not sure. We'll just keep adding hydrogen peroxide, keep the heat on it, see if we can get it to go into solution. It's really not all that much material in there, but what we're going to do is try to get the rest of it to dissolve with some hydrogen peroxide and hydrochloric acid. Here we go. Got a little bit left in the bottom. Let's hit it a couple more times with a little bit of hydrogen peroxide here. 29% hydrogen peroxide going in. I just took a few squirts of the hydrogen peroxide. We've got most of that to go into solution. There's a little bit of material left in there. Let's go for it, I guess. Try putting some more hydrogen peroxide in here. But at some point, it just doesn't pay off to keep trying to get that little bit of material. So we may call it here. I think we've got most of it to go into solution. There's just a few crumbs left down in the bottom of the beaker. Now what we'll do is I'm going to stick a piece of filter paper down in here. Get a little bit of the solution on a piece of filter paper. See exactly what it is we're working with here. Alright, I've got a dark stain. Looks brown, got a little bit of orange up around the edge of it. I can't quite tell. It looks like gold to me. So we may have gold in there. So I'll go from here. So what I think we're going to do now is turn the heat off and let this cool down. Here's our solution that we poured off out of our large beaker that we dissolved with hydrogen peroxide and hydrochloric acid. And if you look down here, we got a surprise. We've got some precipitate forming down there. I have no clue what that is. And the longer I let it set, the more accumulates down in there. So now I've allowed this solution over here on my left to cool off a little bit. We're going to just go ahead and dump this in with this and go from here. This is going to have gold in it. This has probably got some gold in it too, so I'm just going to combine these two solutions. Please remember, that I have only done 3 stock pots before this. This is my 3rd stock pot. Look at that, man. We get some kind of precipitate forming in there. I'm not going to add that to our solution. I've only done 3 stock pots. This is my 4th. I have very little experience with platinum group metals or with the stock pot, so we're making this up as we go. Okay, we're going to dilute this solution here with some hydrochloric acid. Adding the hydrochloric acid to this solution cause some of that precipitate to redissolve. Not quite sure what that is. Don't care at this point. I just want to try to get a result here. So what we're going to do now, the goal here is to try to get the gold out of this solution before we go to the platinum group metals. Now what we're going to do is try to get the gold out of this solution with sodium metabisulfite. I'm using stump out here, which is sodium metabisulfite. We're going to add a spoon of this to our platinum solution that has gold and copper in it. We'll try to precipitate out the gold with this. Sodium metabisulfite will also precipitate platinum group metals if they're present, so we want to get the gold out of here and remove it as quickly as possible. I've got a filter set up over here. We're going to try to filter the gold out of this solution now. Dampening it with some hydrochloric acid. Now what we're going to do is try to filter the gold out of our platinum solution. Here we go. These metals are very difficult to separate. You can never get a complete and clean separation like you can with gold. You put ferrous sulfate in there, and the ferrous sulfate will bring down the gold, all the gold, and nothing but the gold. But with the platinum group metals, they tend to want to stick together and not separate properly. Can't use ferrous sulfate here because that would put iron in our solution. And the next step we're going to do is re-cement the platinum group metals down here on zinc again after we get the gold removed. The benefit of using SMB to drop the gold is it's quick. The drawback is the SMB will tend to drop platinum group metals if they are present, and they are in this case heavily. And so getting close to the bottom here, see a little bit of gold we got on the bottom of our beaker. Down there, you see that? A little bit of gold down there. There's our little bit of gold powder. I'll have to use some hydrochloric acid here to try to rinse it down into the filter. Alright, that's enough. Here's our little bit of gold that we've recovered. Rinse the filter out now with a little bit of hydrochloric acid. The speaker still has a little bit of traces of gold in it with platinum group metal. This beaker back here has got a little bit of gold in it. And we'll get that out of there, but not right now. What we're going to do now is take our filter here. This is our gold that we recovered out of this solution. What I'm going to do is, let's see, I need to set this out of the way. I'm going to take this solution now, and I'm going to pour this in a clean beaker. I'm going to set it up on the heat and try to drive off the SMB out of here before it tries to precipitate out our platinum group metals. Set this up on the heat and start heating that up to get rid of the excess SMB in that solution. Here you can see in the bottom of the flask there was some platinum group metals already starting to precipitate out. That's why it looks black. It's mixed with some gold. And then down here, same thing. I got a little bit of gold left down in the bottom of this beaker that we added the SMB to. It's black. That indicates that we got platinum group metals in with our gold. And then back here is a little bit of gold that we had left in this beaker. And I'm going to get that out of there. Probably just dissolve it and add it right back into the stock pot. It's such a small amount, it's not worth trying to go after individually. I'm going to try to get the gold out of this funnel now in our filter paper. Get it down into a melt dish. Won't be very much, but it's part of our yield. Finally got a result. We've got a little bit of gold here that we recovered from the stock pot. I've got the first few pieces in here that we recovered earlier in the video. Let's throw this up on the scale. And what's that? About 0.7 for that little bit. And here's the button that we just melted. All right, we got 5.7 grams of pure gold. Well, it's not pure gold. This is going to be heavily contaminated with platinum group metals. And what I'll do is I'll just add this in with my next batch of carrot scrap and refine it in there. So this will conclude part 5 of the Platinum Refining Stock Pot 4 series. Thank you for watching.